Have you ever hit a wall in math where something just seems impossible? Well, what if I told you that one of those impossible questions led to a type of number that helps us understand, well, everything, from your phone signal to the secrets of quantum physics? Today, we're going to demystify one of the most elegant ideas in all of mathematics: complex numbers.
So here's the problem, right? We all learn this in school. You square a positive number, you get a positive. You square a negative number, you still get a positive, because a negative times a negative is a positive. So how in the world can you find a number that, when you multiply it by itself, gives you -1? Using the numbers we deal with every day, you just can't. It feels like a dead end.
To get around this, mathematicians did something amazing. They didn't find a new number, they just invented one. They called it the imaginary unit, or just I. And its entire job is based on one simple rule: I squared equals -1. That's it. And with that one little leap of imagination, a whole new universe of math opened up.
And you really have to appreciate the mindset here. I wasn't found under a rock or spotted through a telescope. It was an act of pure creation. It's like mathematicians said, you know what? This problem is getting in our way, so let's just create a tool to solve it. Let's just decide that the square root of -1 exists. Now, this idea was not an overnight hit, not at all. Back in the 1500s, a mathematician named Cardano stumbled upon it but basically called it useless. It took centuries to catch on. You had thinkers like Euler who finally gave it its simple name, I, and then the legendary Gauss used it to prove a huge theorem in algebra. It was a really slow burn from this weird little curiosity to a tool that nobody could live without.
Okay, so this is where it gets really crucial. I isn't just some clever little math trick. It's actually the key that unlocks an entirely new system of numbers. It literally adds a brand new dimension to our mathematical world.
And this is what it looks like. This is a complex number. You see, it has two parts. There's a real part, a, which is just any regular number you're used to, and then there's an imaginary part, bi. So a number, like say 3 plus 2i, has a real part of 3 and an imaginary part of 2i. They're like two different kinds of numbers, fused together into one single entity. If that sounds a little strange, think about a simple fraction for a second. The number 3/8, right? It's one single idea, one number, but it's built from two other numbers, 3 and 8. A complex number is basically the same concept. It's one number, but it's made from two components, a real one and an imaginary one.
And hey, let's clear something up real quick. The name complex does not mean complicated, not at all. Think of it more like an apartment complex or a sports complex. It just means multiple parts are joined together to make a single whole. In our case, it's the real numbers and the imaginary numbers joining forces.
And this is the big aha moment. Real numbers, they all live on a flat, one-dimensional number line, right? But complex numbers, they get a whole two-dimensional plane to live on. The horizontal line is for the real numbers, and the vertical line is for the imaginary numbers. All of a sudden, any complex number, a plus bi, isn't just an abstract idea. It's a point in space. We've literally added a new dimension to how we see numbers.
Okay, so we can visualize them now, which is awesome. But how do we actually use them? How do we do math with them? Well, it turns out that playing on the complex plane isn't complicated at all. The rules are actually super straightforward.
Adding is just so simple. You just combine the parts that are alike, add the real parts together, and then add the imaginary parts together. That's it. So if you have 3 plus 2i and you add 1 plus 7i, you get 4 plus 9i. See? Easy.
Now for multiplication, we get to pull out a classic tool you probably remember from algebra class, FOIL. It's just a handy way to make sure we multiply every piece of the first number by every piece of the second. You know the drill. Firsts, outers, inners, and lasts.
So when we do that, we get 4 terms. But here's where the magic happens. Look at that very last term, 14i squared. Remember our one golden rule? I squared is just -1. So that term turns into a regular real number, -14. That's the secret ingredient that makes it all work. Now we just combine the real parts and the imaginary parts, and boom, our final answer is -11 plus 23i.
Division looks a little scary at first, I'll admit, but it has a very clever secret weapon called the complex conjugate, and it's so easy. To find the conjugate of a complex number, you just flip the sign in the middle. That's it. The conjugate of a plus bi is a minus bi.
And here's why that little trick is so awesome.
To divide complex numbers, you multiply both the top and the bottom of your fraction by the conjugate of the bottom number. When you do that, something magical happens. All the I terms in the denominator completely cancel out, and you're left with a nice, simple real number on the bottom. It makes the whole problem way easier to solve.
Okay, beyond the basic math, there's another really beautiful property that the imaginary unit I has. When you start raising it to different powers, it doesn't just go off into crazy, random numbers. No, it follows this incredibly simple, elegant repeating pattern. Just look at this. It's so cool. I to the first power is just I. Multiply by I again, you get I squared, which we know is -1. Multiply again, you get -I. And one more time brings you to I to the fourth power, which is +1. And guess what? After that, the whole cycle just starts over again. It's like a little 4-step dance that just repeats forever.
This repeating cycle gives us an absolutely fantastic shortcut. So if you want to find any power of I, no matter how huge it is, all you have to do is divide that exponent by 4. The remainder is all that matters. It tells you exactly where you are in that little 4-step dance. A remainder of 1 means your answer is I, a remainder of 2 gives you -1, and so on. Pretty slick, right?
Okay, so the rules are elegant, the patterns are cool. But you might be thinking, what's the point? Is this just a fun game for mathematicians? And the answer to that is a huge, resounding no. This is where it gets real. You know, that name, imaginary, was kind of a historical accident. For the longest time, people really did think they were just a theoretical curiosity with no practical use. But today, they're absolutely essential. We couldn't describe the modern world without them.
And I'm not kidding. This is where it gets incredible. Complex numbers are used to analyze the flow of electricity in our walls. They're fundamental to how we process digital sound and images. They are literally at the heart of quantum mechanics, which is our best description of how reality itself works. They even help create the mind-blowing graphics you see in movies and video games. This imaginary number has some profoundly real-world consequences.
And maybe nothing shows off the power and beauty of complex numbers quite like the Mandelbrot set. This unbelievably intricate, gorgeous fractal image is generated from a super simple equation, z² plus c, where z and c are both complex numbers. You just repeat that simple calculation over and over again on the complex plane, and this infinite, stunning structure just emerges out of nothing.
So, think about where we started. We had an impossible problem. The solution was to just imagine a new dimension of numbers. And that single act of imagination gave us elegant rules, a deep connection to the physics of our universe, and even a peek at infinite beauty. It really leaves you with a final thought, doesn't it? If this is what happens when we just add one new dimension to our thinking, what else might we be missing?